Hi, Billy. I won't make him sing you happy birthday, this time, but happy birthday. We are on 2-3. We're in the last little bits, okay? So, section 2-3, thus far, we've talked about a bunch of different graphs, like 7 of them, I think, probably. And these are all graphs that enlighten. What does the word enlighten mean? Inform. That's a good word. Make what? Yeah. Make you more knowledgeable about the data. It shows you more information about the data. It's a good way to condense the data into a visual. Graphs that enlighten. Good ways to represent data. Now, we are on to the very last page of the notes, which is graphs that deceive. What does deception mean, or what does deceive mean? Like misinform. I like this. You are just misinform? MISINFORM. Is it one?
Or is it uninformed, or is it
Misinform.
informed?
I don't know. Uninformed. Misinform is the correct word, but I feel like, I don't know. Misinform is deception. Graphs that deceive. It gives you misinformation. Okay?
Wait, frequency tables, do they touch or they don't touch?
Frequency tables? Frequency polygon? Frequency tables.
Or is there space?
No, those are lines. Those are not bars. Okay? All right, first type of deceptive graph. There are 2 types that we talk about, okay? The first one is a non-zero vertical axis. Circle that. Non-zero vertical axis. The vertical axis is the vertical one, the y-axis, right? So here's an example, okay? We are talking about experiencing nausea when you are giving Oxycontin. Do you know what Oxycontin is?
Yes.
Like it's a painkiller, right? Okay? So you're given this painkiller and you're experiencing nausea. This many people experience nausea on Oxycontin. This many people experience nausea on the placebo. A lot of times with painkillers, they say that you are supposed to eat food with the painkiller. Otherwise, it will like eat your stomach, right? Like it's not good for you if you do all the things, okay? So, placebo versus Oxycontin. Here's the problem. Both of these graphs are displaying the same information. Ready? This one is starting the graph at 10%, right? This one is starting the graph at 0%. Circle those. Now, if we go the actual values, like what's the actual value for Oxycontin, does it look like? 22? 23%? Let's go 23%, okay? The placebo was how much? We'll go 11% for the placebo. Or 12%. 11 or 12. No, we'll go 11% because that's what it says up here, right? 11% versus 23%, right? Okay? All right, now look at those 2 things. They're both graphing the same thing. But if you look at the bottom one where it's starting at 0, this tower looks twice as tall as this one. True? Because 23% is twice as tall as 11%, right? This is how it should actually be. This is good, right? Versus when they started at a non-zero value. Not 0. Look at what happened to it. They're giving you the accurate numbers. This is still 11%. That's 23%. But this tower looks like 5 times larger than the other one. Maybe even more than that, right? 10 times larger. Okay? So the first graph, when the axis is not starting at 0, this makes it look like nausea is way bigger in Oxycontin than in the placebo. When actually, it's only like twice as much. Does that make sense?
Yes.
Like this one, when you're starting at non-zero, it's like it's basically like we've zoomed this thing in, right? But we've lumped off like part of the bar right here. Like we did not start at 0, and that's bad because it has misleading information. Here it looks like Oxycontin is like 5 times or 10 times what placebo is, when actually it's only like double, a little bit more than double. Okay, so you want to, when you're dealing with a bar chart or anything like that, you want to make sure that he's starting at a value on the vertical axis at 0. Now, it is still okay to do this thing on the x-axis, right? The x-axis is not going to do any problems. Like if my first category on my bar chart starts at 60 and it goes 61 to 70 and 71 to 80, blah, blah, blah. I can start and do that little bit right here, and I don't have to start him at 0. But I want to make sure my vertical axis starts at 0. Does that make sense? okay? Otherwise, your bars look not proportionate, okay? Not proportionate. Your bars do not look like they're in the correct proportion, right? Not proportion. Do you understand why that is? Okay. The second type of misleading graph is a pictograph. You guys have seen pictographs in like 4th grade social studies graphs or 4th grade whatever, math class, I don't know. But here are pictographs. This is a graph that shows you like the relationship between things, but they're using pictures to represent it, and they say that that is bad, and here is why. Okay? We're talking about cigarette smokers. Here in 1970, there was 37% of all U.S. adults that smoked. In 2013, it was 18%, right? 18% is like half of 37, true? Like a little less than half, right? Do we see how this works? This should be double. So what they did was they used a cigarette to represent that, and they did this guy, and then they doubled that distance for the other one. Do you see how that works? Okay? But here's the problem. Because a cigarette is two-dimensional, right? Not just length, but also width, what they did was they doubled this and made this twice as long as well. So now you're doubling the length dimension, but you're also doubling the width dimension, okay? So let's see what happens. Let me relate this back to like a square, right? Let's say I have a square that's 3 by 3 by 3 by 3, right? And let's say I double that now, and now it is a 6 by 6 by 6 by 6, right? Let's talk area, because your eyes are going to see this as an area. What's the area of this guy? 9. What's the area of this guy? 36. Even though I took this times 2, what happened to the actual area? He quadrupled, right? But visually, your eyes see that as quadruple, not double. Even though I doubled both sides, right? Like all the sides are doubled. My eyes visually see this as an area deal, and it looks like this is way bigger than double what this is, right? This looks probably way bigger than double what this is, okay? Because your eyes see it as two-dimensional. Yes, ma'am?
Is there a way that you can only like affect one side so where it is double?
Just doing a bar graph or a line graph or something. Don't use pictures. Yeah, that's what they say. Okay, now, let's say this is three-dimensional. Let's say they used a cube, right? Boop, 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 boop. There's a cube, and here's another cube. Doot. Boy, I'm going to get my whatever in. Okay, this is a 3 by 3. This is a 6 by 6. But what's the volume of this cube? 27. What's the volume of this cube? 216. Good math. Look at you go. Now, this guy is not doubled, right? I did not double each one, even though I doubled those sides. Now my volume is like times 9, right? 27 times 9, is that 216? I think it is. Yeah? So my volume, if we're looking at something that's three-dimensional, my brain sees this as 9 times larger, not double. Does that make sense? So don't use pictures to represent the data that you're trying to display. Because, yeah, I can look at the numbers and see that it's supposed to be double, but my brain doesn't see it as double, right? It sees it as way bigger than that because it's two-dimensional or three-dimensional. So pictographs, stay away from them. Yeah, they're fun in 4th grade, but let's not, like in big kid class, okay? Got it? Concluding thoughts, and then we'll talk homework. For smaller, here's concluding dots. I think you had a question like this on your homework assignment. For data sets that are 20 or fewer, use a table instead of a graph, right? So one of the questions said, here is your data set. Why would we not put that in a histogram? Because it's not enough data. Do you remember that question on a homework assignment, I think? It's not enough data. So if it has 20 values or fewer, just leave it as the table. It's easier to, it's better for me to look at as a table, right? Okay, a graph of data should make us focus on the true nature of the data, not on the elements such as eye-catching or distracting design features, like the cigarettes. Don't do pictures, okay? I should focus on what the data is representing, not the image that's associated with it, okay? Do not distort data, like using a non-zero vertical axis. Do not distort the data by using a non-zero vertical axis. Bad. Don't do that. Okay? I'll do a circle around that one too. Okay. Almost all of the ink in a graph should be used for the data, not for other design elements. Okay. Now, some of you guys go and you guys color in your bar charts, right? And that's fine if you use different colors, like, because that visually helps me. What does not help me? Don't do this.
I know, it's like, it's
Do you remember doing this in elementary school?
it's a mouse, not a curriculum.
No, I don't know. What do we want to do? Like, okay, this is using my pen to like waste time, right? Okay, you can color them in. That's fine if you want to shade them. It does give me a better visual, but don't waste time doing this crap. Okay, got it?
Oh.
What?
We share. We share.
Ha!
We had this discussion.
Nice job. Down, up. That's how you draw a star.
No.
If you do it a different way, you're wrong.
No, now it's sideways.
Stars are lopsided.
Do you do an A?
Yeah.
Oh gosh, now that hurts my brain.
I go the other way.
Ah,
Start on the other. I go
Down.
bottom left.
what?
This way.
Josie's is bad.
Yeah, that's the only way.
What? Do it again.
Bottom left.
You are silly, silliness. Okay, Joe's.
Guys.
Whoa.
Oh, you're killing me, girl. Oh my gosh, this hurts my brain.
I can't do it slow.
I can't even watch.
Yay.
Nope. I can't do it. I can't do it.
That's not good.
How is it
No, I
sideways?
can't do it. I can't do it. I can't do it. I can't do it.
Like this. I don't know how to do that. Hold on. I don't know.
Yeah, you make an A first.
Yeah, and
She makes an A first.
and-
Ah, can't. I can't do it.
You go.
That's the right way to do it? Oh my gosh, you guys
No,
are
this
nuts.
that way.
No.
I do an A, but I just
No. You know what? College algebra. Who's my college algebra kids in here? Ready? I don't remember what it was. Something like this. Whatever. Okay? Okay? Tell me how you do this. I took it home. And guess what? My husband does it the same way as I do. The non-stupid way. No, we're subtracting.
Okay, give me that.
Okay?
No, give it to one of us. You take
No, you don't do that. No, you don't. How do you do it?
9 and 4, then you
Carter's gonna get bonus points. No, he doesn't. No.
That's what you do.
Don't do
Oh, it's
it that
59
way.
now. It's 59.
No. No.
What the heck?
Oh my gosh, you guys. Who taught you? Who taught you?
We do it the right way.
Oh
That's
no.
not even right. That's not even.
Does anybody do it this way?
Hers is so bad.
Oh no, it is not.
It's so confusing.
8, you can't take 9 from 8, right? So you make that 18, and now you're subtracting 5 instead of 4. 10, you do it that way.
What are you doing?
It makes no sense.
Okay, let me go back here. So 18, you're subtracting 5, right? So this is 9, right? Okay, now I can't take 5 from 0, so I make that 10 and make that 6.
Oh yeah, so you take from the bottom?
The non-stupid way.
That is the dumbest way.
Tick, 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 tick. I'm not crossing any crap out. This is the fastest way to do it.
You just have a bunch of.
Oh my god.
Well, I actually like that way better though.
Yes. See?
You can't just put a 1 in front of a 0 and say it's 10.
It's 10. But it is 10. And this is 18. And this is 5 and that's 6.
How is that not 14 and 15 then?
No.
Yeah, exactly.
Because the 1 is down below. I don't know.
Yeah.
On the bottom row you add 1. On the top row you add 10.
That makes
No.
Oh my gosh, whoever was not stupid. I am gonna take this up with Mrs. Crano. No, it would have been, who was my math? Mr. Turner in 5th grade would have taught me that. Actually, 4th and 6th grade he was. You guys are silly.
We'll just ask Mr.
Ah.
Johnson.
So sad. You guys make me so sad. All right, whatever. This is all on video. I hope you're enjoying yourself, Billy. Us fighting about things. All right. Okay. So what?
Thumbs don't party too fast.
All right. So I'm going to give you 10 minutes. You have until 1:30 until it hits the 6, so 11 minutes actually. And this is not going to take you 11 minutes. There are 3 pages of homework, really 2, a front and a back and a third. Yeah, you've already done the one whole page. So all you have left is number 17 and number 18, yeah? Okay, so you have 11 minutes or 12 minutes to finish any graphing that you need to do and to answer number 17 and 18. Okay, then we're going to move on to 2-4. We're going to do some vocabulary, just a little bit at the top. Go.
What is it asking?
How much can I have?
Okay, I'm going to shut this off, Billy, and then I'll reconvene for section 2-4. Okay.